Welcome back, everybody, to the VSAT program. Today we're going to be talking more about available water. All right, we know a lot about available water at this point, or we should. We always measure in inches per foot. It determines how much water is available to the plant in the soil before we hit our permanent wilting point. We can also express it as a percentage. If we know available water, we determine our MAD and understand what a soil moisture depletion is, so we can manage our irrigation cycles more efficiently and so forth. But what happens in soils, and this is common, what happens in soils when, as you go down in depth, the soil types change. All right, so let's just make this real simple. 1 foot of soil here, 12 inches, and you go down 12 inches in the soil profile and it changes soil types. All right, let's say this happens to be another 12 inches. And you go down at this point 2 feet and then it changes soil types again, right? And just for argument's sake, this is another 12 inches and then it changes soil types again, you hit bedrock or whatever. And let's say this is clay and loam and sand. And this is common for soil types to change as you go down, all right? That's why it's important to understand what your soil profile is. Now, the USDA has great websites, and they've documented soils all across the United States. Your land-grant university here in California, University of California at Davis, has a lot of this information as well, so check out those resources. But it's interesting to note that as water is applied through rain or irrigation, and it starts hitting this top layer of soil, it will start filling up this top layer of soil, all right? And it's not gonna spill over to the next layer of soil down, that other soil type, until this hits saturation. And then it'll start draining over, and then it'll start filling up, in this case, clay, now it'll start filling up the loam. Then once the loam hits the saturation, it'll start spilling over into the sand. That's why when you plant trees, you don't want to, and this is what I was originally taught when we're planting trees, whatever the case may be, and you don't want to do this. Now, what some people will say is when you plant a tree, you want to dig a large hole, backfill some of that hole with like a compost or a nice soil or something like that, put the root ball in, and pack it with that nice compost, whatever the case may be. The problem with that is, if you dig this hole, right, here's the ground, you dig a hole, you put some nice compost or something like that in, and then here's the root ball for our plant. The problem is with this scenario is when water is applied to irrigation or rain, water is being applied, right? This space in here is going to start filling up with water, and it'll act like a puddle. Then your root ball is sitting kind of in a puddle of water. All right, now it can cause disease problems and so forth, so we want to stay away from that. And mitigate the same change of soil types as much as possible so we don't have that puddling effect. All right. Excuse me. Okay. Different soil types have different available water capacities, right? We should know that by now. Sand, for instance, its available water capacity is pretty low, right? Because it doesn't hold on to water very well. Where clay tends to be higher because clay holds on to water a long time. All right. And so what this graph represents, you see this graph that you're looking at, and you can see on the left-hand side it says soil texture, clay loam, loam, sandy loam. All right. And then you go to the right, and it talks about depth in inches and then zone thickness. All right. What that refers to is the clay loam is a soil that's near the surface. All right. And it goes down 18 inches. All right. 18, and it shows us that here, right? It says clay loam. It says depth 0 to 18. 0 represents the surface. 18 represents the bottom of the clay loam soil. So it's 18 inches deep. 18 inches is equal to 1.5 feet, right? And that's what it's saying here where it says zone thickness 1.5. That's equal to the 18 inches. And in this case, that clay loam soil has an available water capacity of 2 inches per foot. All right. And then the loam soil starts below the clay loam, so it starts 18 inches down, and it goes down to 36 inches, which means it goes from 18 inches to 36 inches, meaning that layer of soil, the loam layer, is 18 inches deep, and that 18-inch deep layer of soil starts below the clay loam soil, so it starts 18 inches down, goes 36 inches down for a total of 18 inches thick. And that zone thickness, as you see expressed here, 18 inches, is 1.5 feet. And that loam has a capacity of 1.65 inches per foot in available water. Now below the loam soil is sandy loam. And that sandy loam soil starts 36 inches down at the bottom of the loam soil. So it starts 36 inches down under the loam soil. And it goes down to 60 inches. So the sandy loam soil goes from 36 inches down to 60 inches for a total of 24 inches. So that layer of soil is 24 inches deep, or 2 feet, what our zone thickness says here. And that sandy loam soil has an available water of 1.25 inches. So if I was to draw this out, here's my soil profile. We'll kind of treat it like a staircase so it's easy to understand. All right, what this is saying is clay loam soil is near the surface. And this depth is 18 inches, which is also equal to 1.5 feet. All right. Below the clay loam soil, the loam starts. It starts 18 inches down, right? So it goes from 18 inches down another 18 inches, also 1.5 feet. So this is 18 inches down where it starts, and it goes down another 18 inches to 36 inches. Now when we get to the 36-inch mark, it changes from loam soil to sandy loam. All right, and the sandy loam starts at the bottom of the loam soil, which is 36 inches down, and carries down another 24 inches, or 2 feet. And at this point, where the sandy loam soil ends, is 60 inches down, right? Now, if I grow a crop that is deeper than the 18 inches in the clay loam soil, that means I'm dealing with different soil types. Now, why is that important? As you see in the chart here, each soil type has a different available water. So its access to water for the plant in these different soil types changes. And sandy loam has an available water of 1.25 inches per foot. So we need to calculate based on the different availability of waters in a different root zone. If we want to understand how much water is available to a crop as a whole, we got to take all this information into account. All right, but it's actually very simple. But we just need to look at each layer of soil independently, calculate independently, and then add together. Now, how do we calculate water independently for each layer of soil? You actually already know how to do this. All right, the equation we learned at the beginning of the second week, right? Looks something like this: available water times root zone equals our plant available water. Now we have to apply this with every layer of soil based on how deep our root zone is. All right, so in this case, look at our description here. If the RZ, the root zone, is 12 inches, the plant has access to 2 inches per foot for a total of 2 inches of water, right? Because we know that our available water is 2 inches per foot. So in this case, 2 inches per foot is our available water. We times it by the 1 foot of soil, right? Because 12 inches is equal to 1 foot. We always use RZ in feet, 1 foot, and that gives us a paw of 2 inches. Feet cancel each other out here, right? Now what happens if the root zone is 18 inches? Well, if our root zone is 18 inches, we're not dealing with different soil types yet, right? We're still in the clay loam soil, which means our available water doesn't change. So in this case, the available water stays the same, 2 inches per foot. We times that by, how do I convert 18 inches to feet? I divide it by 12. 18 divided by 12 equals 1.5, which is our root zone in this case, feet. Gives us a total paw of 3 inches, all right? But we haven't changed soil types yet. So what happens when we do change soil types? Let's look at that. But we're going to use, again, this equation for every layer of soil. So in this case, the root zone is 30 inches. Now, if I look at my little diagram here, clay loam soil accounts for 18 of those inches. All right, so let's start by just accounting for the first 18 inches of that root zone. My available water is given. Doesn't change. It's 2 inches per foot. So I'm going to write that over here, and I'm going to drag these layers this way. All right? And then separate it here. My available water, 2 inches per foot for a clay loam soil. My root zone, again, we're only counting for 18 inches here. So because we're only counting for 18 inches in this first layer of soil, my root zone is 1.5 feet, right? 18 inches is equal to 1.5 feet. So for the clay soil, my plant available water is 3 inches. But again, that only counts for 18 inches of the root zone. How many inches is left over? Well, if I know my total root zone is 30 inches, now I just need to subtract the 18 inches we already counted for. And that leaves me 12 inches left. All right? So now looking at my chart here, I have 12 inches of root zone left. So again, if I look at my plant that's growing in this soil profile, whatever plant it is, its roots are going deeper than 18 inches, and it's going into about right here. 30 inches down, 18 of that's accounted into clay loam, 12 more in the loam soil. So right about here, the root zone ends. Means there's about 6 inches left here before we hit the sandy loam soil, so we don't have to account for the sandy loam soil because our root zone doesn't come in contact with it. And we only have to account for 1 foot of the loam soil because that's all our root zone comes in contact with, or 12 inches, which we know is equal to 1 foot. So in this case, our available water for the loam soil is 1.65, right? That doesn't change. Available water stays the same. But our root zone, because we're only accounting for 12 inches of the loam soil, because the 18 inches was already accounted for in the clay loam soil, we only have 12 inches left over. So our root zone is now 1. The 12 inches that's left over here. So our root zone is now 1 feet. 1.65 times 1 obviously equals 1.65 inches. Now we just need to add these two together for a total of 4.65 inches. So now I know in a soil with these type of characteristics and a crop with a root zone of 30 inches, how much water is available as a whole. And in this case, 4.65 inches of water is available as a whole. Let's look at another example. Find the total paw for a soil RZ with a rooting zip of 30 inches. We just did that one. Now let's look at 48 inches. All right. So I'm going to go ahead and get rid of these numbers here. One thing that's unique, again, is our available water doesn't change and it's given. So I can leave my available water in here, and in fact, I'm going to plug the sandy loam soil available water in, because that doesn't change if we're dealing with a quarter of a foot or a full foot. The only time it's going to change is when our soil profile changes, the texture type changes, all right? 1.25 inches per foot is the sandy loam soil. All right, so our root zone is 48 inches. If I was to draw that out here, that would mean our root zone is going through the clay loam soil and it's going through the loam soil, right? Because the clay loam soil starts at the surface, goes down 18 inches. The loam soil starts underneath the clay loam soil, 18 inches down, goes down another 18 inches to 36 inches, which means I'm penetrating into the sandy loam soil. How much? How can we determine that? We know the sandy loam soil starts at 36 inches down. So that's going to be accounted for. Our root zone is total of 48 inches. We subtract these two other root zones, 36 inches. Now I know 12 inches left over is where this root zone is going to dead end into sandy loam soil. 12 inches equal to 1 foot. Now this actually gets pretty easy because we can just use our zone thicknesses for the first two layers of soil that are given here. Not a whole lot of math needed. And again, I have them on my board here. The zone thickness for the first layer of soil is 18 inches or 1.5 feet, right? So I'm just going to plug in 1.5 here. The same is true with the loam soil, right? It's 18 inches thick, or it's 1.5 feet. And lastly, by subtracting those two layers of soil from our total root zone, which is 48 inches, minus the 36 inches of these two layers of soil, I'm left with 12 inches left over, which is how deep into the sandy loam soil our roots penetrate, and that's equal to 1 foot. All right. Now we just multiply across and then add the pause down. All right, so 2 times 1.5 was 3 inches. All right. 1.65 times the 1.5 is equal to 2.475. I'm going to go ahead and round up to 2.48 inches. And the 1.25 times 1 is equal to 1.25, right? Inches. Now I add down. So let me add these together for a total plant available water of 6.73 inches. Now I know how much water is available to my plant for the entire root zone. Now, how can I track depletion, especially if I don't have instruments? How can I track depletion? If I determine how much water is available to the plant, how can I track me losing that water to ensure I don't run out? Well, due to the land-grant university system, the state of California and probably all states have set up weather stations throughout the entire state, every county. And in the weather station, they put a patch of grass. All right. And with this grass, they measure ET. What does ET stand for? Evapotranspiration. All right. Evapotranspiration. That means the evaporation of water from the soil and transpiration of water through the plant, right? That's the two ways we can lose water. You combine those two terms, the evapotranspiration, that takes both into account, right? And so what these weather stationers are doing is tracking the ET of a patch of grass. All right, and that's where we can go, and in California, you can go to the CIMMYS website, and it stands something for California Irrigation Management something systems. And we can find the weather station closest to us, and it'll tell us what the ET of that grass is. Now, if you know what the ET of the grass is it the same for tomatoes or apples or avocados, whatever the case may be? The answer is no. All right. That's why on the same websites they give you what they call a crop coefficient. All right. So if we know what the ET of the grass is, we find our crop coefficient for the avocados, and we take the ET, we times it by the crop coefficient, and that gives us the ET rates of our crop. All right. For instance, the ET for a given week might be 1 inch per week. All right. We go to the website, we find that our crop coefficient to convert that patch of grass, to convert the patches of grass ET rate into an ET rate of an avocado tree, the website will tell us what the conversion rate is, what we call a crop coefficient. So for instance, if our ET, again, is 1 inch per week, we times that by whatever the crop coefficient is, and maybe that says 1.2, which means for our avocado trees in this instance, for that week, we lost a total of 1.2 inches of water. And if I know what my total plant available water is for the crop that has a 48-inch root zone, I know I can go nearly another 5 weeks, if ET doesn't change, until I'm running out of water. Again, that's going to help me manage my system better, apply water when I need to, and not be useful and be most efficient, and again, get the most out of my crop. All right? And that does it for us today, and we'll catch you next time here at BSAP. Thank you.